Okay, this is a video on changing dimensions. So this topic is all about just investigating what happens when we change the dimensions of shapes and what happens to some of our calculations like perimeter and area and volume and surface area. So let me just show you an example. So here we have a rectangle with dimensions 6 centimeters by 4 centimeters. So maybe we just want to investigate what happens when we change the dimensions. So first I'm going to just find the perimeter of this current rectangle. So it currently has a perimeter of 20 centimeters. I know because, one sec, this side would be 6 and this side would be 4. So I know that 6 plus 4 plus 6 plus 4 would be 20 centimeters altogether. And then what if I wanted to look at what would be the area of this rectangle? So area is length times width. So 6 times 4 would be 24 centimeters squared. Now maybe I want to see what's going to happen if I double all of the rectangle's sides. Okay, so I'm going to double all the side lengths. So instead of 6, the new side is going to be 12 centimeters. Instead of 4, it's now going to be 8. So I doubled the sides. So this will be 12 and this will be 8. We want to see like how does that affect the perimeter and the area of the shape if you double each dimension. Okay, so let's check the perimeter. What do we think is going to happen? Do we think the perimeter will be doubled? Like will it be 40? Do we think it'll be quadrupled? I don't know, let's find out. So the perimeter now would be 12 plus 8, which is 20, and then plus another 20. So now the perimeter will be 40 centimeters. So it took the perimeter from 20 to 40. So we doubled the dimensions and it actually doubled the perimeter. So that's interesting. So now what do we think will happen with the area? Will it double the area as well, or will it have a different relationship? So let's see. To get the area, we multiply length times width. So 12 times 8. So 12 times 8 would be 96 centimeters squared. So how did that affect the area? So the area didn't get doubled because 24 times 2 would be 48. So what did happen to the area? If you're not really sure, one way to figure it out could be to divide the area. So take 96 and divide it by 24 and see what you get. Okay, so if I do that, 96 divided by 24 is 4. So actually what happened was the perimeter got doubled, but the area was quadrupled. I feel like I'm gonna spell that wrong. It got multiplied by 4, which kind of makes sense, right? Because the area formula is length times width. So now if we're doubling that and we're multiplying, it has an extra effect, so it's gonna get quadrupled instead of just doubled like perimeter. So it's like, wait, could I say something like, yeah, if it was length times width for area, but then over here we doubled it, so it was like 2 times the length multiplied by 2 times the width, that would equal 4 times the length times the width. Okay, awesome. So that's one thing we figured out. So let's check out a cube. So in a cube, we would investigate volume and surface area. So if we had a cube and we were wondering like, I wonder what will happen to the volume or the surface area. Okay, let's see. So if we wanted to find the volume of this cube, volume of a prism It's just length times width times height. So this shape would just be 4 times 4 times 4. Which would be 64 centimeters cubed. Okay, and then if we wanted to find the surface area of a cube, we know the surface area formula would be 6 times base squared, because we have 6 sides and they all have the same dimensions. So if we do 6 times 4 squared, we would get 96 centimeters squared for the surface area. Okay, so then what happens if we double the dimensions? So on this side, we're going to double all the dimensions. So instead of all being 4, now we're going to switch them to all be 8 centimeters. So this one will now be 8, this one will be 8, and this one will be 8. Okay, so let's see what happens with the volume. So length times width times height. So we have 8 times 8 times 8. So that would give us 512 centimeters cubed. So if I divide that by 64, so if I take 512 and I divide it by 64, I can see that the volume actually increased by 8 times as much. So like 64 times 8 would give me 512. So even though we just doubled the side lengths or multiplied them by 2, the volume ended up getting multiplied by 8, which does make sense because volume is like we're multiplying these 3 things, like this times this times this. So instead of just getting doubled or quadrupled, it got multiplied by 8. That's like 2 times 2 times 2. So that kind of makes sense. And then let's look at the surface area. So surface area is calculated by 6 times base squared. So we would have 6 times 8 times 8. So that would be 384 centimeters squared. So let's say I divided that by 96 to see what would happen to the surface area. It looked like it got 4 times as big, which makes sense. It stays consistent with our area one. Area is just getting quadrupled or 4 times as big. So perimeter gets doubled if we double the side lengths. Area gets quadrupled and the volume gets multiplied by 8 times bigger. So that's kind of just like, that's what changing dimensions means. Like you could change your dimensions and then kind of investigate like how do perimeter, area, volume, and surface area respond to a change in dimensions. So it's kind of just an investigation to see what happens.